Okay. Okay, now I hope you see. You see, miss?
I see it. Yeah, perfect, bro. Let's go
Okay.
to the.
Okay,
So we were
we just
reading the
started.
docs. Did you got some understanding of what's happening? Let's or not? Um,
Actually, no, I didn't understand anything.
Perfect, perfect. There's no problem. So let's start with line 21. Okay.
Okay.
What are you seeing on line 21?
I see that the contract lottery inherits from iLottery, ticket, lottery setup. There are different contracts, and this contract inherits from them.
Awesome. So on line 21, we can see that lottery has an interface. It also inherits from ticket. It inherits from a setup system, and it inherits the contract for the referral system. And RN source controller must stand for randomic number, probably randomic number source controller. There's also a contract doing that. Now, if we look at line 22, what do you think is happening in there?
Mm, okay.
Don't need to think too much. I'm going to explain you, okay? So, what we're doing in there is we're saying that every implementation that uses the interface for ERC20 will implement methods from safe ERC20. It means that you're kind of composing the ERC20 type, you understand? You adding functionality to that type. So
Okay.
it's not only the ERC20 interface anymore, but it's also
Where
now.
we are adding to IERC20.
Yeah, we are
Where
adding the safe ERC20 specification to the ERC20 interface. That's useful so you can.
where does this specification comes from? From this contract?
Yeah, from one of these contracts. I don't know which
From one of
one.
these contracts?
Yeah, because I don't know which one because we didn't import all of them. But one
Yeah.
of these contracts has this safe ERC implementation, okay? And
Yes.
also
Yes.
one of these contracts has the interface for the ERC20. What we're doing in there, we kept the code separated and we are kind of composing something, you understand? Usually because this
Yes.
safe ERC20 is not yours, you're just using that from some standard library. Actually, look at line 5.
Yeah. So yeah, it comes from
Open
yeah,
Zeppelin, right?
Open Zeppelin.
So yeah, so we know that this is a standard, is not real. So that's why we are composed. So we don't only want the ERC20 interface, but we want the safe implementation of that, you know?
Yes.
With that information, you kind of understand what's happening in line 23?
Okay. We are using this ticket utils, which is this from line 11,
Yes.
SIC for
For UIN
unassigned integer
256, yeah.
for you.
So yeah,
Yes.
so we are implementing all the functionality that is in ticket utils, which must be like by ticket, some division or calculations. We're doing that. So all the numbers will automatically have that functionality, okay?
Yes.
Let's go to line 25 now, and we can see a private ID. I guess that every lottery, let's say every lottery match, let's call it match, has an ID. So
Mhm.
the lottery from today is an ID, the lottery from next week is the next ID, and so on. Then we have this 26 line front end do ticket sales, which is a mapping composed of address and a value. Probably by the name, I imagine is the amount of tickets that the front end sell. Sold. Okay.
Okay. So I'm not very familiar with the mapping
Let's talk
proposal.
about mappings. It's very easy. Okay. A mapping is just you know what an array is?
Yes.
So a mapping is a little bit like an array. So can you go on line 25 and at the end of the line and do an enter? Do an enter in there. Just do
Which line?
enter. The line where I know. Just do an enter. Perfect. Now I want you to copy what I'm sending here on the chat. So I'm gonna send this, say
Okay.
this is a user. Okay, imagine that the first one is an address and well, let's say 10 enter. Just copy that. That ain't gonna work, okay? That is not function Solidity, but I'm gonna be able to explain you mappings from that. So a mapping is just a way to create a hash map indexed by some information you want, okay? And
Mhm.
what is the index in this case that we're seeing on line 27? The index is the address, okay?
Yes.
So you have address and you have the little symbol and you have you win 256, okay?
Yeah.
So look at line 26 now. This is
Mm-hmm.
kind of how a balances mapping would be represented. So I would have, when I have 0x1, I would have the user address. And whenever I get information from that address, I'm going to receive the amount of ether that that address has. You understand? So it's just a way to list information based on an index. Okay. So if on line 27 we are looking at mapping address to Uwin 256, means that we're gonna have the address of the person who bought the tickets. Okay, and the you win
Mm-hmm.
256 is going to be the amount of tickets that they bought. You understood?
Yes.
Feel free to if you don't understand, let's do something. Let's do something. I'm going to make you understand.
Okay. Maybe I can try to code it.
Yeah, let's create a new file. So just go over and create a new Solidity file contract.
Okay. Okay.
Awesome. And let's create a contract called contract. Let's call it a Z token. Perfect.
Like this.
Yes, space.
Mm-hmm.
The space and do open and close brackets. Yes, put the pragma solidity 0.18. The pragma is outside the contract, so before line 1.
Okay. 0.
The pragma is outside the contract. So go on line
Yeah.
1 in the beginning of the line.
Yeah. Yeah. Yeah.
Pragma solidity 0.18.0. 0.8.18. Sorry. Perfect.
Okay.
Yes, you forgot the Y on solidity. Now,
Yes.
perfect, bro. Now we're gonna let's say that this is a token, and we're gonna create a mapping to represent the balance of each user. Okay.
Yes.
So let's create a mapping called balance. So you can say mapping. Actually, you can say mapping. Yeah, mapping address to you win 256 because the address is gonna be the index and the 256 is gonna be the value. We can call it
What's the
balances.
name?
Balances.
Balance.
Balances, yes, perfect. Make it public. So put public before balances, okay? It's before. Perfect, bro. Now, let's create do an enter two times. Again, let's create a constructor. So say constructor. Let's put parentheses over the.
Uh,
I think after lines. Oh no, perfect. I think this works too. Now, what we're gonna do is we're gonna set a few balances, okay, for some people. So
mhm.
let's say that balances, and then you can put the array thing, the array thing. Yes,
Yes.
perfect. And inside the array thing, inside the array thing, yes, say address. open and close parentheses, and say 0x0. Or just 0. Perfect. Just 0 is better. Just 0. Oh, awesome. Just say equal. After,
After
yes, after, yes, perfect. There. Equal space 10 ether. Space ether. Yes, perfect. 10 column. So what we did in there, we just specified that address 0, of course this is not a realistic case because this will be like a board, but we're saying the address 0
yes,
has that balance. You understand? Now let's create
yes.
another balance to address 1. So just copy that line, paste below, and put 20 ether to address 1. And imagine that we just use an ether because our token also has 18 decimals like ether.
Okay. So what are we now supposed to do?
So just put 1 instead of 0 there because we're going to be converting. So just so you know what we're doing with this line, right? Address 0, right? And address 1.
Mm-hmm.
We are converting 0 to an Ethereum address and converting 1. So it's just going to give us some random address, but it's good to test, you know? So
Yes,
now
yes.
I want you to do something, change on line 8 to instead of 10 ether, 20 ether.
What should I do?
Instead of 10 ether there, put 20.
20.
Awesome. Now we're going to create a function. So go on after the constructor, yes, and create a function called get balance. Perfect. Now
Okay.
you're gonna pass a uint 256 number. Perfect. You don't need the prefix because this is not. Yeah, just say number. Yes,
Mm-hmm.
perfect. And then you can
But
call
when is mandatory to use the prefix?
when you have a variable with the same name. Usually, you're gonna be using the prefix, you know. But
Mm-hmm. It's a convention. It's a convention in Solidity.
no, yeah, in programming also you have this convention for private information. You usually do a so if balances were private, balances would have a underline in the beginning of it. Okay.
Yes,
Um,
it's because I was reading I was doing the crypto zombies, and they were saying that we use prefix when the contract is private.
yeah, yeah, not yeah, yeah. For private stuff, usually you're gonna do the underline in front of it. Okay.
Mhm. So in this case, we don't need the
Yeah,
prefix.
we don't really need it. So because this is a because you're just gonna be reading from the blockchain, this can be a view function. So after, so you can do get balance, and you can say
View,
public view,
okay, public
actually
view, read.
external view, sorry,
Actually, what?
external view, not public. You know the difference between
External.
public and external?
So the external means that uh, it can be used by other contracts. This contract can be used
Yes,
by the other
exactly.
contracts.
Yes, in public is
And the
both.
public is public only you can view. You can't use on your
No,
contract.
no.
Am I
So
right?
no. So with public, you can read it from the contract and in
Yes.
other contracts. Okay. From a contract and from other contracts. With external, you can only read it from another contracts. Okay.
Okay.
So the only way to call would be to use the these for public functions, these whatever, and then it works because you keep the context that way. So external view, and we're gonna return a uint 256, which is the balance, right? Okay.
Yes.
So closing brackets, and now what we're gonna do is we're gonna simply return
Okay.
balances address. Same thing you did. Yeah, I'll put the address. Now instead of putting a fixed number, we're gonna put number. And this is it. Just put a semicolon. So let's take a look at this code and see if you can understand what it's doing.
Mm, okay. This comes from this.
So we're gonna pass 0 and we're gonna get 10, and we're gonna pass 1 and we're gonna get 20, right?
Yes. Yeah.
Awesome. So let's test it. So let's try to compile it.
Um,
Click on auto compile there. Yes, click on that and let's see what is the error. Line 6. This is because you need the parentheses after constructor. There's constructors, open and close parentheses. Yes, right in there. Yes, perfect. What is the other
yes, and
error? Go
this
down,
SPDX.
go down. You cannot convert an address to a number. There's no problem. We're just gonna just remove the address thing from there. Just change from number to address. So let's do this. Okay, so change from number on line 10.
Mm,
Change from number to address. Not in there. Not in there. Yeah, actually the type. Okay, the type is address instead of you win 256.
mhm.
Perfect. And then you can remove on line 11, you can remove the conversion that you're doing because it's already an address, so there's no need to convert to address. When you're doing address number, you're converting a number to an
Yeah.
address. There's no need to do that. It's already an address. Okay, awesome. This should work. Let's go over the deploy and let's deploy it over the virtual machine. The last tab, last one. No,
Mhm.
yes, this one. Just click on deploy. Perfect. Go down. Okay. So we have a function now where we can read the balances from users. Let's go. I want you to open another tab.
Uh,
Not in there,
okay.
in the browser itself.
Ah, in the browser.
Yes. I want you to
Okay.
Google for Web3 type converter. Perfect.
Okay.
Click on the first one. Awesome. Now put 0 on the type that you want to convert, the first thing, and convert it to address. You're gonna have the conversions in there. I think you can put bytes 30, bytes 32. Apply padding. Click on apply padding. Now copy. This is not 40, right? This is gonna break because this is not an address. Can you go and search Ethereum
Yeah.
born address? So Ethereum address 0.
Uh,
Just go on Google and search Ethereum address 0. Copy that. You see? 0 address on the first. Yeah, this. Copy this. Awesome. Okay, now let's go to remix and let's try to get the balance from 0 and see what if you get the 10 back. Go down. Not in there, no. Control Z. Go down there.
mhm.
In this, go to the left.
Mhm.
Go down. Yes, and to go on the get balance.
Yes.
No, don't click paste the number.
Mhm.
Now click on get balance. You see? You
Yes.
you were able to read the how much what was the balance of tokens from address 0. Now change from 0x0 to 0x1. Just change the no control Z. Yes,
Yes.
just the 0 after the x becomes 1. Just that. Yes. Yes. Now try that balance. I think this is not the
Okay.
1. I think this is not 1. That you see the return is 0 there.
Yeah. Yeah.
Because this is not 1 actually. I think 1 is with the last 0 being 1.
Let me search for it.
Yeah. Yeah, it's the last one being 0. Um okay.
I don't see the one. I don't see. Oh, so now I think it should work. Yeah, we see. Okay, so now try to get the balance.
Mm-hmm. Click on. You see 20. So what a mapping does is just stores information for you in a way that you can query it based on something. And in this case, you're basing yourself on addresses, like you define on line 4.
Mm-hmm.
So imagine you have a function. Now let's create a function to set a balance. So go on line 12, do an enter, create function set balance.
Okay.
Now let's pass the address, right? Because we need to pass the address. So let's say address, let's call it user, maybe user. Okay. Oh, maybe wallet. Wallet is better. So let's say wallet.
Yeah.
Awesome. Now comma. What is the second parameter we need to pass?
Number.
Yes, the amount of balance of the user. So we're gonna pass you in 256 amount.
Okay. You
Remove the
went.
number. No, remove the number. Remove this. Just yes. Just do comma. You int 256 and amount.
Number.
Amount.
Amount.
Yeah, that's good. What you're gonna see more in
Okay.
code.
So what we are doing now?
Now what we're gonna do is we're gonna set a value in the mapping. You understand? So we're gonna take.
Uh. Yeah. Go further.
Let's do it. So go after the function. Yes, the space
Yes.
external. Put the functions as external.
Yes. External.
And I want you to we're gonna return or we're gonna return. Yeah, we're gonna return a boolean because if the value is already set,
Yes.
we're gonna return false. Okay.
Mm-hmm.
So go on line
Okay.
14, and first thing we're gonna do is we're gonna check to see if there is already a balance in this address. So if balances were in wallet,
If balances.
now
Okay.
the array thing, remember? You query
Yeah.
we,
Yeah.
what we should put in there inside the array thing. If we're trying to read the balance for a specific wallet, what we should put in there?
Amount.
No, the wallet, right? I mean, we're trying to search for what by the
Ah, the
wallet.
wallet.
Yes. So we're looking in the balances mapping to that wallet. So put wallet in there. So if if
Okay.
if this wallet is different than 0, so you can do different and you can do 0. I don't know if you can do 0 like you should do 0 like that. I think yes, 0 like that works. So what that
Mm-hmm.
means is there's already a value in that wallet. Okay. So we're
Mm-hmm.
gonna do the brackets of the if. Yes, and we're gonna return false in that case. And if not, go down on line 16, do an enter.
Okay. Else.
No else, no else.
No else.
Just do an enter after the if. Enter,
Uh.
enter,
Yes.
enter, press enter. Yes, perfect. Now you're gonna set the balance. How do you set the balance of the wallet?
Mm,
Take a look at line 7.
okay. So in our condition, if the balance is different than zero, return false. Else,
No, don't
we
think on else.
should.
Now we're just setting the we need to set the value of wallet inside the mapping balance. How do we do that?
Mm,
Just look at line 7.
yes.
So you do balances,
Okay.
the array thing.
Uh,
What we're gonna set?
wallet.
Yes, wallet. And is equal what?
Uh, it's equal.
Look at line 13.
Amount?
Yes, bro, right? You're setting the amount of the wallet. So that's first it is amount. Okay? So
Yes.
put the same column. And right below it, you're gonna do what? Return true,
Mm,
right?
yes. If in this case we need to
Just return
return
true.
true.
Now see, look at the function and see if you can understand it and how it's interacting with the mapping.
Okay, so we have a wallet, we have amount, we return boolean, so we have condition which we take our balances from the wallet is equal to address. If it's different than 0, we need to return the return false.
Because it's already set,
Else,
right?
because it's
Because it's already set, there's already a balance in there. In this case, we don't set.
yes. If there in these balances is there's any amount
No, so if there's no
which
balance, so if it didn't get into the if, there's no balance in that wallet. If balance is zero, then we set the balance to be equals the amount, right?
yes,
Now, how do we make this function more safe or safer?
more safe.
Safer. How do I make it? What are we not
Mm,
checking? What are we not checking? Like, you know,
let me think about it. So
like should you be able to set a balance that is zero?
should I be able to set a balance that is 0?
Yeah, like imagine that you're trying to set the user balance. What I'm trying, I mean, this is not a really realistic case because you do want to set the user balance as zero, right? When he does some sort of withdrawal. But what I'm trying to say is you can make this function more stronger by validating the amount to making sure the amount is not zero or is not some weird number. You understand?
Yes.
So
Uh,
on line 14, okay, go on line
yes.
14. And after the zero, put a logical and in there. So two E signs. You know that company sign, that E and sign?
Uh,
Two of those.
okay. 2.
Yes, space.
Okay.
And amount different than zero. Actually, no. If amount is equal zero, sorry, not different, but equal. So equal in solidity, two equals, right? You're comparing, right?
Yeah.
So yeah, so put two equal signs in there. Amount
Uh,
equals zero should be amount equals zero, right? You're comparing, you're
equal
not
equal.
setting.
Yeah.
You're comparing, you're not setting. Okay, awesome. So let's take a look at let's read this line. So if the balance is not zero in the wallet, or if the
Yes.
amount, actually, sorry, I say to use and, but should be war, should be or. So it's two pipelines. Actually, wait a second. If the amount is not zero or the amount is equal zero, return false.
So this we need to put pipelines.
Yeah, so this is an or. Okay, the other one you had was an
Yeah.
and. Uh,
And
so
or
this,
so or
yes, I think you can also type that if that
mm,
works. No, it doesn't work. Doesn't work.
I don't think so. I think it's the pipeline, the two
Yeah.
pipelines.
So what we're checking
Unless
is
I'm
we're
making
validating both the wallet for not being zero and the amount. If the amount is zero, I'll also return false. Okay. So
mm-hmm.
this makes the function a little bit safer. You could also, because now we're fiddling with address zero, we're not really validating that, but you could also validate, like, you can also not use address zero. you know, you know, this is actually a, so you're doing an audit, right? You're looking at code. Every time you see an address in a function, usually it's good that it's validated against zero. Okay. So just to show you how that would look like in the code, go before the if on line 14 and do an enter. No, before the if on line 14.
Uh,
14, before, yeah. Do an enter in there. Go on the line above and do a require and put address. Sorry, wallet. Sorry, not address, but wallet. Require wallet. It's different than just one in there, right? With the
yeah,
if.
one. The one equal.
Yes.
One.
Address zero.
Address
Zero.
zero.
Yes. Just put
Okay.
a semicolon in the end. And so this is a validation that you should do for most of the smart contracts, because what we're doing is we're validating that, you cannot, why would you set balances for address zero, That works for burnable tokens, these things, but I'm just trying to explain you here, and I hope you kind of understand it, that this will be a stronger function because now we're validating against zero for the address, we're validating against zero for the amount, and we're making sure that the wallet has no balance before. Does that make sense? That clarified a little bit of the mapping things for you?
Yes, yes. I'm starting to understand.
So let's go back to the ctf.sol.
Okay.
And now that we have that situation, you kind of understand what's being stored on line 28. But look at line 29. We have a mapping of a mapping, dude.
Mm-hmm.
So let's try to fiddle with that case too. Go back to your contract and let's implement a mapping that is a mapping of a mapping. And let's call it a guild. So it's gonna be like a, or better
New
yet,
contract.
no, this contract. Let's go on line
Mm-hmm.
5. And I want you to create a new mapping. And let's put it in address. And let's put it into another mapping. So you're gonna say mapping again.
Yes.
And you're gonna say address to you in 256. And let's call this mapping public governance.
The internal mapping or the
This one,
external?
this one. Let's call it public governance. No, it's after, yes. Public governance. Perfect. Put a semicolon in there, off. Perfect. So, bro, look, what I'm trying to do with this mapping is creating a sort of governance scheme. So think like this. There's your address, and all the people they are delegating their tokens to you. So by your address, I load the mapping that has the address of all the people and their amount of tokens. You understand?
Mm,
Think governance,
okay.
think delegation, think governance, think governance, think that I have these people that they can receive your voting power and vote for you. Okay, have you seen these
Okay.
delegation schemes already? These in crypto?
No.
So in crypto, there's something called delegation. Imagine there's a protocol. Okay, and
Mm-hmm.
but I cannot, but I don't want to make every user vote because that's inefficient. Okay, it's better for me to have a certain users that concentrate the amount of vote of each user, and then I have a smaller surface of decision, and maybe it will lead me to a better decision scheme in the ecosystem. You understand?
Yes.
So imagine any kind of committee, where you have the main persons and everybody that voted as persons, so what they represent. So that was what we have with governance. We have your address and everybody that believes in you and how much tokens they are giving you as voting power. Okay.
Hmm.
So now what we're gonna do is we're gonna go on line 8. We're gonna do a new line below 8, and we're gonna create a pre-delegation, like we're gonna create a delegation scheme for 0 and 1, like we did, for the balances. So let's do
Okay. Okay. So
governance
how governance?
address 0, right?
Yes.
So governance at address 0, we need to save another mapping. So we're gonna put another array thing in there,
What should I put?
another array thing.
Okay.
Yes, and in there we're gonna put who delegated this vote. So let's say that 3 and 4 delegated their votes to address 0. So you can put address
Mm-hmm.
3. No, 3, I mean the number, right?
Uh-huh.
The conversion.
Uh,
Perfect.
okay.
Yes, awesome. Equals, not in there. Right? After, right? Yes, equals. Let's say 3 ether.
Um,
3 ether. Yes, perfect. Semicolon. So let's look at this line. Let's try to understand it. So what we're saying is that delegated to address 1, 3 ethers. I want you to copy that line and put it in the line below. Change from 3 to 4, and on both places. So address 4, it will be 4, and address in 4 ether 2.
so here I need to replace with 4.
Yes, perfect. And just replace the ether to the amount of ether with 5 instead of 4, because the numbers are not related. So
Okay.
just there's no relation. Awesome. So what we're seeing that is that user 3 and user 4, they delegated around 9 tokens, 8 tokens, sorry, 8 tokens
Yeah.
to the address 0. Okay. So when you see a mapping of a mapping, it's just a way of relating one index with several index. You understand?
Yes.
Or no, you don't understand? Be honest, bro.
Uh, so
Tell me what you don't understand. You can even say everything. I don't understand nothing.
this okay. Uh, can you repeat about this governance?
So I don't want you to think on token governance, okay? I want you to think that let's change the word governance to borrow. So go on line 5 and replace
Okay.
governance with borrow. And let's think that this is now a borrow amount, so a certain amount of money that someone borrowed to you. Okay, so go on line 9 and 10 and replace governance with borrow. So all the information that we have in there on line 9 and 10 is that address 3 and 4, they borrow 8 Ethereum to address 0. You understand?
They borrow 3 Ethereum, and the other 4 borrows 5 Ethereum.
Yes, and
Ether, excuse me.
yeah. So I mean, this is just a way of storing information in a way that you can. It's not about borrowing, it's not about governance, but we're talking about the mapping itself. It's just a way of you correlating information. So if you have a mapping of misanthropic friends, and this mapping would be my address, there will be your address and true for a boolean.
Mm-hmm.
So you understand how the mapping that makes it clear? No.
Uh, not really.
Okay, let's try this. I want you to implement. I want you to erase line 7 and 8. Okay. Also, I want you to erase line 4. I want you to erase the get and set balance functions. get and set balance, you can remove this function. Remove this one. Perfect. Let's change from z token to, let me think, on, let's call
Okay.
Azarian um Azarian X. Okay, let's say that this is a contract that lets you know how much money you have on each one of your, you have related. No, let me think of something that is easier to see. Let's call this contract a Azarian friend list. Okay, put friend list. Perfect. Awesome.
Okay.
Now I want you to replace borrow with friends. Don't forget line 5. I want you to remove line. I want you to remove the constructor.
This.
Yeah, the whole thing. Remove this friends equals to friends. You can remove line 6 and 7. Now let's create a function called add friend.
Okay.
And instead of Azarian friend, let's just call it friend list.
Okay.
So on line 3, you can change from Azarian friend list to just friend list. Perfect. And this function add friend, what kind of parameters you think? One more thing, on line 5, change from UE 256 to Boolean, so we know if they're friends or not. So go on, yes, perfect, perfect. So what parameters do you think we should put in the add friend function?
Hmm. I think about it. Um. Okay.
How does a friendship relation works? You know, we have two parties, right?
You have to meet first
Yeah,
someone
you have two
to.
parties, right? So if you have two
Yeah.
parties, you're gonna be pretty much passing two addresses, right?
Mm-hmm.
So let's go. Address,
Okay.
address,
Okay. Unit
address. Can you hear me?
address.
Yes,
Yes.
address.
Yes.
And then you can say space.
Yes.
Let's call it a. I'm just thinking about, because we're gonna have to do this in a way that is easy to understand. Let's call it my friends. Okay, my friends. So my friend. Awesome. We don't even need to pass the other address because I'm gonna make this function in a way that only the message sender is already picked, automatically. So we can already add you to the message sender. Okay. So
Mm-hmm.
declare it as public external, actually external, and it's gonna return a boolean just like the other one. So we can do a little bit of an if thing in there. Okay.
Yes. Boolean. Yeah.
Yeah. Just now open and close brackets and okay. So explain to me what this function does. What it's gonna do.
Hmm. Uh, I'm struggling. Uh, this function should add friend.
Yeah, to you, right?
So
I should add a friend to my address,
to
right?
my friend list. Yeah.
Yeah,
To
to my
my
address. So
address.
message sender is in play here. So
Mm-hmm.
this mapping could be different. This mapping could be address to address. I'm just trying to show you how mappings inside mappings works with a boolean, so it's easy for you to understand that too. Okay.
Yeah.
So let's do a require. First require that we're gonna do is we're gonna make sure that you're not already friends with someone. So how do we do that?
Uh, uh,
First we look at friends, right?
okay, we are looking at friends.
Yes, friends. So type friends.
Is different, maybe?
No, it's an array thing,
No.
right? It's in a mapping. Isn't friends a mapping? It's a mapping.
Mm-hmm.
There's So what are we looking at there inside the
If
mapping thing?
uh, if
Inside the array thing. Inside the array thing. What are we looking at? Which position of friends are we looking at? Inside the array thing. Go inside the array thing.
yes,
What are we looking at? What are we looking for? If I'm looking to the person that is sending the transaction, what I'm looking for?
address,
Message.sender, right?
message to sender.
Yeah.
So that means
So type message dot sender. You know what that means? You know what that is?
mm,
No, right?
barely. No, no.
Yeah, bro. I thought you knew Solidity. You don't know Solidity, but that's okay. We're gonna teach you. Okay, there's no problem.
Yes.
So message sender is the person that is sending the transaction. Okay.
I didn't hear it. Can you repeat again?
Message sender is the wallet sending the transaction. So if that's your wallet,
Okay.
it's gonna be you. If that's my wallet, it's gonna be me. You understand?
Yes.
Awesome. So let's do another array thing.
Okay.
And now we're gonna put the my friend parameter. Maybe you can replace friends with friend just so it's singular and it's easy for us to understand there's not there's only one in there, not two. Okay, so what we're looking at is inside this mapping of me and this address, is it true or false? If it's true, so just the require the way it is, just put a semicolon in there at the end. The way it is already works because it's a boolean, it's gonna return true and it's gonna match the require. Okay. But
Mm-hmm.
so sorry, Azarian. Should be the contrary position. So now we actually want to make sure that this is false. There's two ways, right? We can do my friend equals false after the array thing, or we can add an exclamation before the friends. So I think the exclamation is better. So go to write the F in friends, yes, and put an exclamation in there, which is a negation.
Uh,
Put exclamation. You know the exclamation mark? No, exclamation mark, like
uh,
this one here. I'm gonna send you on the chat.
okay.
Oh, sorry, I sent the wrong one. This one.
Oh yeah.
Not this one, not this one, not this one. Yeah,
Yeah. Okay. Explanation.
awesome. So you know what that means?
No.
Yeah, it's false. So if you remove the exclamation, you compare it to true, and if you leave the exclamation, you compare it to false. You know. So this requires.
Yeah. Oh yeah, 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 yeah. Yeah, I forgot.
Okay, no
Yeah.
problem.
So
Awesome.
it checks if it's false.
Yes. So so now you can go to the line below because there's no sense in adding a friend they're already having there, right? And
Yes.
we're gonna simply add the friend. Now you could also do another require here to say, oh look, require that my friend is not address zero. So let's do that for to make the function stronger. So require. You can start the same. You can do the
Uh.
same thing. Exclamation. My friend. Sorry, bro. You can
Uh.
no. You can erase everything into the exclamation thing and just say my friend. Remove the exclamation too. Remove the exclamation in there too.
Okay.
my friend is equal, is different, sorry, than address 0. Perfect. Put a semicolon in the end. So look at what you're doing. You first requiring that there's no relationship before on line 8. And on line 9, you
Yes.
require that my friend could not be 0. Why would I be friends with 0? You understand? Always validate address for 0. And there's an error. What is the error that Solidity is complaining on line 7? Can you put the mouse over the red thing? I think is returns, not return, right?
Yeah. Returns.
Bro. Now, what we're gonna do is we're gonna go add a new line below the require, and we're gonna set the value of this friendship to true. So how do we do that? We start with friends on open the array thing, message.sender, which is me, the person sending the transaction, my wallet. Okay, awesome.
Okay.
And now put another array thing, my friend, right? The address of my friend. Awesome is equal true.
My friend is okay.
Equal true in the end, not inside. Yes, equal true. No, 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 not in there, not in there, not in the end.
Here.
Yes, yes, equals true.
Okay.
Now read that line and tell me if it doesn't make sense for you. And look at the
So
mapping.
okay. So here says that if
I have a question for you, which is why are you using a mapping of a mapping and not just like a mapping of an address to an address? Because I can have more than one friend, right? Not only one,
mm,
right?
yes, we have more than one friend.
Yeah. So now does the mapping makes a little bit more sense?
A
Let's
little bit.
let's
Yeah.
deploy it and let's test it and let's see, let's make a function to get friends. So just click on the trash bar, the trash thing in there. Yes.
Yes.
And create a new function in the code to get the friendship status. So go on line 11, do an enter, and create a new function called get friendship, get friend. And you're gonna pass the address of the friend again. And you're gonna return a bool, same thing. External returns bool. Perfect. Now all you're gonna do is return friends. My wallet. How do I say my wallet?
Um.
Friends, message sender. No. Yes, message sender. In my friend too, right? Because I need to see that specific relationship. So I need to check that position, right? So remove the
Yes.
semicolon, add another array thing, and my friend. So now we're gonna see if the relationship is true or false. So let's put a semicolon in the end. Let's deploy this contract. Go down, click on the thing, go down, and now let's do this. Let me show you how to use Remix and what you're doing. Go up a little bit in there. Awesome. You see the account thing, click on that. So this is several accounts that the virtual machine gave you with Ethereum. And you can see that this account that you're using has a little bit less Ethereum because you're spending with deploying contracts.
Already gas. Yeah. We spent already gas.
Yeah. So let's do one thing. Let's copy. You see, right below this, you have the copy symbol. Click on the copy symbol so you can copy their address. And let's check. Click on the copy field.
Yes.
Yes, that. Go down and go on the get friend function.
Okay.
Okay. And you're gonna pass that address in there. and do a get friend.
Okay.
Click on the get friend.
Okay.
Sorry, this function should be a view. Can we deploy it again? Just change line 12 to external view. Perfect. Just deploy. Click on
Uh,
the trash can.
okay. But what about the
Deploy the
line 7?
this one. No, why? Because let me explain you. Good question. Line 7, we are adding a friend. We're not viewing enough. We're not getting no result, right? I mean, actually, you're right. We could remove the return ball from, let's go on line 7. Let's remove the returns boolean. Let's just say external, like straight up, So remove the return. There's no returns. This is a bad practice, but it's okay. Let's add a few errors too. Go on the require.
Mm-hmm.
And right after the last array thing, with my friend, yes, put a comma and then put double
Yes.
quotes, comma, not semicolon.
Yes.
Double quotes and say already friends. And for the one below, you can say can't be address 0. Just a little bit of information regarding doing this. The bigger the message is, the more expensive is the gas you're going to be spending to execute that. You can also use error types, but we're not getting to those at this point. It's just for you to understand the mapping thing.
Okay,
Can
so
be
this
address 0. Yes.
okay.
Awesome. So let's click on the trash can, deploy that again. Click on the copy, so we can copy that address. Go down and see, go on the get friend now and paste that address. Get friend, not friend. Yes. Click on get friend, and you see the result is false because there's no relationship in there. We never added a friend, right? We never used the function to add. Now let's add this friend, and we're gonna add this friend to your address. Just want you to stop a little bit and think about this. Okay. On line 10, we're using message.sender. Go up where you are right now. Go up. Better
Okay.
yet, better yet,
Now,
just paste the address that you copied in there. Because we're using the virtual machine and that address is selected in there, this address will be message sender. You understand?
mm, not really.
Okay, so let me try to explain. What you're doing in there is you're trying to simulate you executing a smart contract, right? You,
Yeah,
you
yeah.
agree with
I'm
me that
executing smart
every smart contract is executed from a wallet or from an address, let's say. Every function, right?
Mm-hmm.
There's no magic, right? If I'm gonna do something, I need to click the button on MetaMask, don't I? Or you never used MetaMask before,
I used.
but very little.
Uh,
No, be honest, bro. There's no
I didn't.
problem. There's no problem. There's no problem. Okay.
Yeah, I was using it on Patrick Collins' course at the beginning. Yes, you can see
Awesome.
here.
No, no problem. So let me just explain you something. Open Uniswap. Open Uniswap and open your MetaMask too. Put your password in there. Leave it ready. Okay. Awesome. Now click on Launch App and click on Connect Wallet. Awesome. Perfect. I want you to do nothing now. Bro, what you just did in there was you connected your wallet to a Web3 application, which is Uniswap, right?
Yes.
Let's say you had some money in there and you wanted to exchange. So just put 10 there in the Ethereum thing. Okay. Yes. And yeah, put select token. Let's say you had 10 Ethereum and you wanted to change for, you can put WBTC, whatever. Okay. Awesome. Now I want you to think on something. What's gonna happen is MetaMask. Now what's happening is, let me explain what's happening right now. Okay. MetaMask,
Mhm.
Uniswap is talking to MetaMask that is connected to a Ethereum server, okay? And it's asking what is the balance of our friend Azarian. And he's looking at your address and seeing that you don't have enough Ethereum. But basically, when he's looking at your balance, he's just calling a function, could be in a smart contract or not. In this case, because we're talking about Ethereum, there's a specific function for balance. But let's just change from Ethereum to another token. Let's change from Ethereum to DAI. Perfect. DAI is perfect. Okay. Awesome. So, bro, what's happening there is we're trying to buy $10 of Bitcoin. And he's looking at your balance of DAI in the smart contract of DAI. And
Yes.
he's looking at the mapping that has the address of Azarian. There's no DAI in there. So automatically he's returning to Uniswap that, Azaria doesn't have any DAI. And all we're doing in Remix is we're simulating that interaction. We're simulating the execution of the functions. The front end is doing some of that for you. Can you go to Remix again? Can you go up on the close to the account frame? Yes. When you see environment merge Remix VM there,
Yes.
he's simulating a MetaMask environment for you. So it's like when you click on the button, instead of clicking in the front end, it's like you interacting with a MetaMask account. So if you click on injected provider MetaMask, click on that.
It will connect to MetaMask.
Yes. It's gonna connect to your MetaMask, and then you can deploy these on the testnet, and then you need to have testnet tokens and all these things. Go back to the
Yeah.
VM,
Yeah.
go back to the VM, go back to the VM, and go back to Uniswap 2. So let's say that you had some money and you went through with this bot. We had to click first approve. So you will approve the and can you please open Google and click the ERC and search for Open Zeppelin ERC20? You know what Open Zeppelin is?
Actually, no.
Open Zeppelin is the most trusted team in DeFi. They do the standards for smart contracts. They fuck up, but it's really, really rare to happen. So all the standards you see, like ERC20, ERC20 mintable, all you see. Better yet, look at contracts here in the left. You have access control, you have governance. These are all contracts that they made and they're safe for you to use for different things. There's one for tokens, there's one for NFTs, there's one for governance. So
Yes, I know ERC 721 is for NFTs.
yes. So they have standards for everything. But what I want you to do is to go down this page that you are right now and try to find the reference for the contract on GitHub. Not this, not the menu, but the page. Yes. Go down the page, go down, and see if you can find the link to GitHub. Let's click on this ERC20 preset pauser, you see, because that's gonna lead us to GitHub, and from there we can, yeah, just click on that. And then I want you to click on the ERC20 folder. Now go up, go up. Click on the ERC20, yes. And now search for ERC20.sol. Open it, go down, go down. So, bro, what you're seeing there is pretty much the code for 99% of the tokens. This is a framework or a library you could call that Open Zeppelin created, quite safe, so when you click on approve in the DAI, so go back to Uniswap now. Now imagine you had money and you went through with this transaction. So instead of insufficient DAI balance, what would you have in there would be approved DAI. So you would click approve
Yes.
DAI. Now go back to the contract and search the approve function. Control F, approve. Go enter and search for the stop there. So when you click approve, what all you're doing is through MetaMask, you're executing this function in the smart contract. And look at line 137. You don't need to think why the message sender is written differently for now, but just look, there's also using the message sender. You see?
Yes.
So we're reading from the wallet. So what we're trying to do here is, okay, this dude told me that this address here can spend this amount of DAI tokens, which means that the Uniswap router will be able to move tokens from your wallet to the pool and give you the tokens back for that.
Uh-huh, now I get it. Yeah.
You get it now?
Yeah. So whenever so this function proof function, it from this example from the Uniswap, which is integrated with MetaMask, it sees that so message sender is my
Your
account. It
wallet?
sees
Yes, your wallet.
if I have enough amount, it will approve.
No, it doesn't even look at the amount. I mean, I don't know. Actually, can we go back? Can we go on line 138 and click on the approve function and get inside the approve function? Just go with the mouse over it and click on control, and you should be able to know on the function name itself, the approve word. If you can click on that, no? Okay. So let's.
No.
Okay, so just go up and there's a function in that. Now that's perfect, bro. Okay, go back to the approve function. That's perfect because we're just talking about that. Look that on line 138, the approve function that is calling has a underscore in front of it
Yeah.
because I have the let's say the interface, the approval interface, which is the function, and the internal function that will be actually called. So let's search for Control F underscore approve. So you can actually see the code of approve. Okay,
Yes.
stop there. And you see all the approval function is doing is all the stuff we've been doing so far with mappings. So all it's doing is it has a mapping to a mapping of two addresses for a UWIN 256. So we pass the owner, we pass the spender, and we pass the amount. And I want you to pay attention to something very interesting in there. Okay.
Mm-hmm.
On line 214, you have the internal thing. You see?
Which line?
314.
Okay.
There's an internal keyword. You see?
Yes.
So why this function is internal and he has the underlying prefix to it, and the other one is external, you know? I'm gonna explain you why. Okay? From the other function, we always reading message sender, which means that
Yes.
the wallet is uh, uh, calling this function. Okay, but
Yeah.
calling this function directly enables you to set the allowance of anybody because it's not using message.sender, it's just using an address on line 311. So I could say, okay, Azarian's wallet approved me to spend everything and I just take other DAI in your wallet, you know? And that's why the function is internal, because by being internal, only can be called inside this contract. Therefore, it's safe because we know that it's only going to be called in that context of message sender. You kind of understood?
Mm, so it is an internal.
And you
Okay.
see how interesting, like the requires we talked about, is requiring on line 250 and 16. The spender and the owner are not zero. You know, we're
Yes.
talking about always verify against zero, always verify against zero, you know? Uh, uh,
Mm-hmm.
so I understand that this is a little bit harder to understand. So let's go back again to the approve function just so can and you now you're gonna understand. Okay, so go back to the approve function, the one without the maybe just open another tab copy the URL and let's put it side by side. Awesome. Now, let's put it side by side. Actually, you don't even need to put it side by side. Just look at this function. Now imagine, Azarian, how long you've been coding?
For about a couple of months.
Azarian, one of the most important lessons in development is making reusable code. Okay, it's making
Yeah.
code that you can use in several contexts. And you may ask yourself, why do I have two approve functions? What is the why? Imagine that I only had one approve function, just this one, and all that code that is inside the other function was inside here. But instead of passing the owner like we passing on line 138, we just sending message sender. Okay.
Mm-hmm.
Then, no matter what is the context in the future, I cannot use that function separately. If you just search for approve, just search for approve in there, in the contract. You see there's 5 instances. So there's 5 pieces of code that are using the same function. So the reason the
Yeah.
function is split and internal is because we need to keep the code reusable and smart. So look at this, spend allowance. Every time that you spend all, go back to the function that you're right now, the spend allowance function. Go back to spend allowance.
Okay.
Spend allowance.
Allowance.
Yeah, search for spend. Search for
Okay.
spend. Spend. SPAND.
Spent. Okay.
Go to spend allowance. Yeah, this
Spent.
one. Stop. Um, by reading the name of the function, what do you think the function does? Just by reading the name.
It spent money.
It spends the amount of tokens you approved, which means that if you approved 20 tokens and you spend 10, this function will be executed and we're going to remove 10 tokens from your allowance. So you cannot spend 20 anymore. You can only spend 10. You understand?
Yeah, so if you have, for example, 20 token and you want to spend 10, it will remove 10 and you will left by 10.
Yeah, so you're only gonna be able to spend 10 more with that approval. And look at line 339.
Yes.
So it's pretty much calling approve again, but now we're getting the current allowance. So now he could spend 20 but he spent 10. So now we're setting your allowance to 10. You understand?
Mm-hmm. Yes,
And
because we already spent.
take a look at line 334, and this function is also internal, meaning that it's called inside the context of the contract. And that's why on line 331, we're sending the owner and not using message sender, okay? Because it's the internal function.
Yeah.
Now let's go back to Remix. So does mappings make more sense for you? And do you kind of understand what the message sender is doing on line 13?
Yeah, a little bit. So I will try to understand more.
I'm gonna give
Tomorrow,
the
maybe
the
next
the,
days, I will
the most
try
important
to.
pill, Azarian, is if you don't use the protocols, if you don't use Uniswap, get testnet tokens and use testnet stuff. Take testnet, whatever. If you don't use the protocols, you ain't gonna learn because crypto is really couply tied to what's happening in the protocols. Okay.
Yeah, I'm not so absolutely not familiar with the protocols.
YouTube, bro.
Uh,
YouTube will teach you everything.
yeah,
6 hours
yeah,
of
yeah,
YouTube, you're gonna know how to use MetaMask, how to use Remix. But I think you have a really nice basis today. It's gonna be much less scary, and it's gonna make much more
yeah.
sense for you to look at a contract. Okay.
Yeah, I saw the smart contract programmer DeFi playlist. He has his there's videos about
Without using the
Uniswap.
protocols, that's gonna be really sound great for you. You need to take a look on how the protocols work. Okay, so take a look at Uniswap, take a look at using MetaMask. Some videos on YouTube
Yes.
will solve that for you. Okay.
Yes. Okay. Okay. I'll
Thank
do
you
it.
so much, and this is it, bro. Talk
Thank
to
you
you
so
later.
much too.
Bye
Thank you so
bye.
much too.